project Apparel recommendation system using machine learning is actually demonstrated on IPython notebook. For IPython, to open an IPython notebook, we use this command Jupyter space notebook. Yeah, that was actually a spelling mistake. Jupyter notebook. If it's in Linux, we have to open the terminal and use the same command. So this is the Jupyter console where we will be having our IPython notebook files where we have implemented our project. So this is the IPython notebook on which we have tried different modules of the project. It will take some time to load because there's a lot of data on it. So basically this JSON file is the file where we have data of 183k apparel products of the category women's tops. So this is the IPython notebook. Here we are importing all the packages we need for the implementation of the project. So SL in this can be run. I guess my laptop is stuck. So we can run this particular cell by clicking this run command, run icon. So here we have a wait symbol. So the system is asking us to wait for that particular cell to execute. So after that gets executed, this wait symbol will be turning into a notebook symbol, which is the IPython notebook icon. So now this turned to a notebook symbol. Now we'll run this command, this cell even. After that, if I run this cell, now if you observe, we don't have any output. So we have the wait symbol here, and after that wait symbol turns to IPython notebook icon, we'll be able to see the output of this data.shape of 0 and 1, which is the number of data points which we have, that is 183,138 apparel products, and we have 19 features. But in our project, we'll be using only 7 features out of these 19 features. We will be using only 7 features. In the data cleaning process, we remove some duplicates. For example, we have these shirts. These shirts are all similar, and the titles are also similar, and the title only differs in the last few words. That is, a size. The size will be in the last few words, right? So it is not ideal to recommend a product of size L to a customer who is looking for a product of size S. So to solve this problem in the data cleaning stage, we will be removing the 3 duplicates out of the 4. This is just a case where we are demonstrating the data cleaning process. Finally, after all the cleaning process, we have 16,042 apparel products on which we'll be performing our bag of words, TF IDF, IDF word to work, TF IDF weighted word to work, IDF weighted word to work, and weighted similarity using brand and color, and also the visual based product similarity. So this 16K apparel data preprocessed is stored in a pickle file. This is the sample data of the 7 features that we are using in our project, and this is the data after the data is cleaned, preprocessed. This is the data from the 16K apparel data. So we have ASIN, which is Amazon Standard Identification Number, brand, color, medium image URL, product type name, title, and the formatted price. Here if we observe, the titles are all in small case. So in the pre-processing stage, we have converted that uh, the titles into small case, and we have removed the special characters like apostrophes and commas. Coming to the output recommendations, we are applying the bag of words algorithm on the product of ID 12566. 12566 is the ID of the product. This is the product, a t-shirt on which a tiger and zebra stripes are there. And the title of this product is Burnt Umber Tiger T-shirt Zebra Stripes XL Double XL. And this 20 is the number of similar products we want to the query product. So using bag of words, these are the heat maps where we'll be showing the distance between the word and word in the query product and the recommended products. So in this heat map, for example, if we have the word called tiger. So tiger is already present in this. So this is the value is 1. So the recommended products to this particular product are these. This is a product on which there is a tiger and also zebra stripes, but the color on the top of the shirt is different. So similarly, these are the products which are getting recommended, which are almost similar. This came because there is a word called t-shirt and bag of in our title. So these are the outputs that we got for the bag of words. So this this product will be a very similar product to our query product. So these are the products which are recommended by bag of words. At the end, we have some irrelevant products. This is only because there are no words matching with our query title. So this is happening because bag of words is considering only the word frequency in the titles. Coming to the outputs with TF-IDF, that is term frequency and inverse document frequency, which uses the TF-IDF values. So here also we are implementing the algorithm on the same product of ID 12566, and we get 20 similar products to this query product. This is our query product. Okay. So the title is Burnt Umber Tiger T-shirt Zebra Stripes XL Double XL, and this is our product image, apparel image. So this has already appeared in our bag of words. This already appeared. This already appeared. If we observe in the previous bag of words, we didn't have this stripes t-shirts and stripes uh, products in the first very 5 similar items. But in TF-IDF, the output has the quality of the output recommendations has increased when compared to only bag of words. So here even we get some irrelevant product recommendations. So next, this is only about the only IDF. We'll be using only IDF. So the same is used, like 12566 is our product ID, and we get 20 recommendations to the query product. This is our query product. So these are the 20 products. Coming to the output recommendations of Word2Vec, Word2Vec is basically very intelligent when compared to TF-IDF, IDF or bag of words, because Word2Vec knows how words are related. For example, in bag of words and TF-IDF, if there are two words like tiger and tigers or tiger and stripes, they don't know that models do not consider the relativity of these two terms. But Word2Vec knows that tigers is a plural form of tiger, and a word like stripes is somewhat related to zebra. So this adds the intelligent feature to the recommendation system. So by the way, these are called heat maps, which we are using only to demonstrate the outputs in our projects, and these may not be used in the real time. So again we are using this 12566 product ID of product, which is, and the title is this is the query image. So here, if you observe, all these are zeros. This is because the Euclidean distance between these words will be 0, because a Euclidean distance between two similar words is always 0. So double XL and XL it's 0, but for XL and double XL the distance is 2.2. For tiger and stripes we have a distance 4.4. This is basically the heat map, and with word to vec we have the recommendations like this. Though this has already appeared, these are also already appeared. I guess we didn't see this particular product in the previous three models. So this has appeared only because we have zebra in we have this word zebra here, and in our query title we have the word stripes and also zebra. So Vertovec knows that stripes is related to zebra, and hence it gives this product as a recommendation. So these are the products which we get in Vertovec. Even here we have some irrelevant products, however. So this product we never got, because it would be ideal if we recommend a stripes related product to a person who is searching for animals related t-shirts. So we have IDF weighted word-to-vec model. Here we will be using word-to-vec and also the IDF values. So for this we have the outputs for our query product as these. So that was up to here. So here this was the last product. Here in this product there is a word called cheetah. So this word cheetah is related to tiger. Word2vec recognizes this particular feature, like bag of words and TF-IDF never recognize that tiger and cheetah are related, but this does. Next comes the weighted similarity using brand and color, where we give some weight to our brand and also color. So here we have 12566 as our product ID and 20 as our number of recommendations that we need, and 5 and 5 are the weights given to both brand and color. We can change these as, like, if we want products of the same brand, and if we want to recommend only the products of one particular brand, we can give more weight to the brand. So these are the recommendations that we get using weighted similarity. So again we got a leopard here. Coming to visual features based product similarity, we have used the VGG16 CNN, which is an open source which was built by Oxford University's group called VGG. So we get a 300 dimensional vector, not 300, it's 25,088 dimensional vector, where we have several features in that of the image. So here we'll be using the query image, and here we are not using any title or something. So we are using only the query image, and the Euclidean distances are found for the vectors to the other images in the database, and the products with images whose Euclidean distance is very less are recommended first. So here we have Euclidean distance from the input image as 0.044, and here it is 30. So, and here it is 41. So it goes on increasing. So the product with least Euclidean distance will be displayed first. In the similar way, we have these as our product recommendations using visual features based product similarity. So these are the final outputs. Here even we get some irrelevant recommendations. So we have seen some techniques like bag of words, TF-IDF, IDF, word-to-vec, weighted word-to-vec, TF-IDF, weighted word-to-vec, and we have also seen weighted similarity using brand and color, and finally the visual product based similarity. So to build a real world solution, we also have other technique called collaborative filter based recommendations, for which we don't have the data. In collaborative filtering based recommendations, the companies, giant companies like Amazon, use the data of users. Like that is basically that basically goes like this. For example, if you are user 1 and there is some other user 2, if user 1 views three items called item 1, item 2, item 3, and if user 2 uh, views the item 1, item 3, and some item 4, and there is another user 3 who views item 1, item 3, and then item 5. So if some new user comes in and views item 1, he'll probably get recommended the uh, item 3 and item 2, because item 3 has been viewed by two users, that is user 2 and user 3. So this data is not available for us, so we have not choose that collaborative based filtering. So to build a real world solution, uh, giant companies like Amazon, Flipkart, and all the e-commerce giants use these collaborative filtering based recommendations and also content based recommendations, and combining all these and all the outputs from uh, bag of words, TF, IDF, and whatever, and all the techniques, they'll be applying some business rules. Like if a person wants to if a company wants to recommend products of only one particular brand because he has a business relationship with that particular company, so he'll be applying a business rule, like for example, display more products of one particular brand. So he'll be using, so the companies will be using business rules on the outputs of all these algorithms, and finally get the final output recommendations that we see in our emails and also on e-commerce websites. Thank you for listening this. The product recommendations uh, have become very sophisticated these days.